So this is one of these problems where you're given a rate and a time, and you have to use it to find a distance. So they tell us that the boat is traveling 18 miles per hour for 7 hours. So the first thing you need to do is multiply those two to find the distance, 126 miles. And that's this distance here. So now we have a triangle, and we know this side, 350, and this side, 126, and we know the angle between them, 22 degrees. Well, it's not exactly what we want, but we can use that to find side C, the last unknown side in the triangle, using the law of cosines, and that's what I'm doing here. And that comes out to be almost 238 miles. Okay, so that's not the answer, but that's a step in the right direction. Now that I have all three sides, I can find either of the two angles remaining using the law of cosines. And that's what I'm doing here. I'm finding angle B by rephrasing the law of cosines. See if you can understand the way I've fed things into this. Okay, this is the version of the law of cosines that starts with b squared equals c squared plus a squared instead of c squared equals a squared plus b squared. Right? And I'm using it to find angle B. And angle B turns out to be 146.5 degrees. And of course the angle we're looking for I've represented as angle X. That's the angle that the boat has to turn through to point itself toward Barcelona after passing the storm. And as you can see, angle B and X are supplementary, meaning that they add to 180. So to find X, I just subtract 180 minus B, and I get 33.4 degrees. Okay, so a multi-step problem. We had to use the law of cosines twice. When you learn about the law of sines in 10.2, you find that there may be an easier way to do the second part of this. If you have two circles that are tangent to each other, then a line joining the centers is going to pass through that tangency point. What this means is that the triangle they want us to make, which I've drawn here in the top diagram, the triangle ABC, each of the sides of that triangle has a length equal to the sum of two radii. For example, the side AC, which I'm going to eventually call side B, that side has a length that's equal to 13 plus 8.23. So that turns out to be 21.23. Side A has a side that's equal to 11.27 plus 8.23, and so it turns out to be 19.5. Okay, so that's an easy way to find the lengths of the sides of this triangle. To find the angles, we're going to have to use the law of cosines in its inverted form, as you see here. Once we do that one time, and we find, for example, that angle A is 50.2 degrees, we could use the law of sines, now that we know how to do that. Or we could use the law of cosines again, in its inverted form, to find angle B. Once we find two of the angles, of course, the easiest way to find the third is to just remember that the angles in a triangle have to add to 180. And that's how I found angle C, 73 degrees. So in this problem we have a parallelogram. That means opposite sides are equal in length and parallel. So I've labeled those pairs of opposite sides A and D. And angle A and angle D have to be supplementary because they form a straight line. They've given us the hint that the diagonals bisect each other. So that means if the green diagonal is 6 centimeters, then each half of the green diagonal must be 3, and each half of the red diagonal must be 6.5, since the entire thing is 13. And then they told us that one of the angles was 42 degrees. Now the way I've chosen to draw this, that has to be angle A, because angle D is obviously obtuse, meaning bigger than 90, and to find angle D we just subtract 180 minus 42 to get 138. So we've got our angles, and the question asks us about the side lengths for the parallelogram. So to get at that, I've taken pieces of this parallelogram and drawn them as triangles. This triangle here comes from the right part of the parallelogram. It has this side A, this side is 6.5, and this side is 3, and I know this angle 42 degrees. So it's just a straightforward law of cosines problem, and I set it up like this. Solving for A, I get 4.72 cm. And then, to find the other side of the parallelogram, I use the triangle at the top of the parallelogram, the one I've drawn here, with the unknown side D. The other two sides have the same lengths, but the angle opposite D is different. It's 138. So again, I set up the law of cosines like this, and then I solve for D, and it's almost 9 centimeters.